Okay, software is working out. Get, uh, I believe, are you on the group, the WhatsApp group? I think your mom is on that group. So I'm sending the live stream. Okay, so basically we're just going to look at the exam questions because it essentially covers what we did. Looking at our scheme of work, we have series, differentiation, further differentiation, and integration. So without wasting much of our time, I'm going to go straight into the series because these are very important topics that we need to do. So I will do a live frame for the exam question. Okay, so let me get the series. Okay, so in this chapter, we're going to be looking at let me give you this. So we're going to be looking at so objective of this topic. One, we have used the expansion of A plus B raised by N. Use the expansion A plus B raised by N, where N is a positive integer as 1. So for 2, recognize arithmetic and geometric progression. Recognize arithmetic and geometric progression. That's for 3. That's for 2. And for 3, we have the use of the end formula and so on and so forth. So let's start with the first 2 objectives for this lesson. Okay, so these are what we need to learn at the end of the day. So when we talk about binomial expansion, we are talking about the expansion involving 2 terms or 2 items in the bracket. So now there's a general formula for the binomial expansion of 2 items. So let's start with the first. Initially, let's say n equals to 2. So when you do the expansion of this, you have a squared plus 2ab plus b squared. Okay? Now, when you do the expansion of this to the power of 3, you're going to have a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, I want to ask you that, how am I getting the expression without actually expanding it? So I'm going to introduce you to what we call Pascal triangle. And from the Pascal triangle, generalize for any value of 10. So for a plus b raised to the power of 4, we have a raised to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b raised to the power 4. So now let's look at Pascal triangle. I believe you've learned about Pascal triangle, right? So Pascal triangle tells us how to collect the equations of a binomial expansion. So the upper part of the triangle starts from 1, then we have 1, 1 here. So with this, yeah, so you can generate all the other sequences. So this is 1, 2, 1, 3, 3, 1. Okay, so you are aware of this, right? 6, 1, 1, 1, and so on and so forth. Now, which means that if I ask you to find for a plus b raised to the power 5, you need to compute the subsequent one. So this is going to be 5, 10, 10, 5, 1. So the expansion is going to be, so we have 2 10. The first 10 carries the highest power, then plus, then 5, which is the quotient. A draws, the power of a draws by 1, b increases by 1. Plus, we go to the next quotient, 10 a raised by 3, b squared plus 10 a raised by 2, b raised by 3 plus 5 a b 4 plus b 5. So it's like you're aware of all this stuff. Now, aside using Pascal triangle to find the coefficient of the binomial expansion, you can also use what we call what they call it now, combination formula. So let's look at how you go about that. Okay. Now, to understand how to use combination formula, it's more like you have 2 items, all right, and then you are trying to drop in. Let's say you have 2 baskets, all right, basket A and basket B, and you're dropping 5 items into each of those baskets. So this one is telling you that
all the basket A holds all the five items. You get it? This one is telling you that what the basket A holds four items, while this holds one items. This one is telling you that basket A holds three items, while this holds two items. Okay? The sum of the total items that they are holding must always be five. Do you understand? So if we turn it into a combinatory story, so if we have A plus B raised power of n, then we know that whatever value that we assign to our A, whatever we assign to our B must be less than that. So for instance, if B holds k items, then A has to hold what? N minus k items. Do you get it now? A, so if B holds k items, A has to hold what? N minus k items. You get it? Because the total sum of what the two baskets must hold has to be constant. Do you understand? Now, we also know that in this arrangement, the order is not actually important because if you have an expansion, please look up. Let's say you have an expansion like this, a squared b, and then you have an expansion like b squared. This is counted as the same, what do you call it now, combination. Because at the end of the day, if you, what do you put it now? If you rearrange this item, it's still going to be the same. Okay? Can I read it differently? So if you rearrange this product should be the same. So how many ways can you arrange the product of two items such that item A and item B such that item A occurs twice and item B occurs once? So it's more like adding something that is A, B, B. Okay, so if I'm going to ask you how many ways can that be done? Total number of ways is 3, right? Wow. Now, since I'm selecting B once, so I can see two identical things. So that's 2 factorial and 1 factorial. Am I correct? Based on what? Combination. Or this is still the same thing as saying what? Out of 3 items, I'm selecting B once. So either you say 3 combination 1, or 3 factorial, or 2 factorial, and 1 factorial. Do you understand? So in the same way, if I have A items, in how many places? In n minus k places. So I have A, in n minus k places. Then I also have B, in k places. Then the total number of ways of arranging this item is going to be what? N factorial by n minus k factorial, which is the same thing as what? N cubed. You understand? Do you understand? So which means this item can actually occur how many number of times? N times k number of times. And since we are always taking the sum from the lowest amount when the value of b is 0, because the first item is when b is 0, and the value of b increases gradually from b equals to 0, b equals to 1, b equals to 2, b equals to 3, up to the maximum number. So I'm going to put the summation sign here. So this summation sign tells us that this thing initially starts from 0 and goes to what n. So this is the general expression for binomial expansion of two items. So we'll write it down. Okay, so can I do this part? Can I do this part of the question? So the general expression is given like that. So let's do raised to the power of 3. And B, we have 5 minus 2x raised to the power of 4. So let's use the linear expansion. So for the first one, 3x minus 2 raised to the power of 3. So which means there are two variables, right? So the value for a is 3x and b is minus 2. So using our general formula, we know that a plus b raised to the power of 3 is going to be a cubed plus 3a squared b plus 3ab squared plus a cubed. Okay? So now we recall that a is 3x and b is what? Negative 2. So therefore we have negative 2. This is what? Surplus. So recall that a is 3x, so this is 3x plus 2 raised to the power of 3 is going to be 3x raised to the power of 3. So we just replace our a with 3x plus 3x, 3 times 3 raised to the power of 2 times 2 plus 3 times 3x times 2 raised to the power of 2 plus 2 raised to the power of 3. So which becomes 3x raised to the power of 3 is going to become 27x cubed plus 3x squared is 9x squared. 9x squared times 3, that's 27x squared plus, okay, am I correct? Times 2, that will give me 27 times 2, that's 54. So this is 54 plus, this is going to be 3 times 3, that's 9. 9 times 4, that is 36x plus 2 is plus 3, that's 8. So now we have the right terms. I think we are all in the other terms. So 3x plus 2 is plus 3 gives us 27x cubed plus 54x cubed plus 36x plus 8, which is exactly what we're looking for. For the second one, so let me just read this. So for the second one, so we have 5 minus 2x raised to the power of 4. So using our binomial expansion, so let's name all this to be what? A is 5 and b is what? Negative 2x. So a plus b raised to the power of 4, using our Pascal triangle, so it will be a raised to the power of 4 plus 4a cubed plus 6a squared b squared plus 4ab cubed plus b raised to the power of 4. So this is going to give you, so 5 raised to the power of 4 plus 4 times 5 raised to the power of 3 times negative 2x plus 6 into 5 squared times negative 2x all squared plus 4 into 5 times negative 2x all cubed plus negative 2x cubed. So simplifying this will give us 5 raised to the power of 4, that will be 625 plus this is 5 cubed. 5 cubed is 125, right? 125 times 4, that's 125 times 4 is what? 600. Am I correct? That is 20. 4 times 2, 8 plus 2. 4 times 2, 8 plus that's 10. So that's 500. So 500 times negative 2 will give us negative 1000x plus 5 squared is 25. 25 times 6 will give you 150. 150 times negative 2 will give you negative 300 x squared. So that will be plus because negative 2 also is plus. Then we have minus 4 times 5 is 20. 20 times 8. 20 times 8, that's 160. So negative 160 x cubed. And then finally we have plus 2x raised to the power of 4. Hold on, there's a mistake here. So this is 6 times 25 times 6, that's 150. This should be 150 times 4. So this is going to be 600 right? So this should be 600. Yes, 600 x squared plus 20 times 8. 10 times 8 is 160. So this one is correct. So this is negative 160 x cubed. And finally, we have negative 2x equation of 4. That will be plus 60 x raised to power 4. Okay? All right. You can do all this, right? All right. So if you can do all this, then let's look at more practical questions. So, let me look at questions that other kinds of questions they ask. So what about if you are asked to find, looking at a question, just hold on. Find the ascending powers of x, the first four terms in the expansion of 1 plus x raised by 15. How are you going to do that? Find the ascending powers of x, the first four terms in the expansion of 1 plus x raised to the power 15. So can you just maybe explain? Hello, Penny. Slept on. I was asking you a question. If you have an expansion of 1 plus x raised by 15, and you have to find in ascending powers of x the first four terms of that expansion, how do you go about it? Just give me an explanation of how you. So the information is 1 plus x raised by 15. So if 1 plus x raised to the power of 15, 1, 5. Yeah. 1 and you're looking for the first term. Yeah, the first four term in ascending powers of x. Mm. You swap ascending, not descending. You swap. You'll be having x plus 1 raised by 15. Like, okay, let's start with the first term. What's the first term going to be? Okay, what about second term? No, second term. Second term cannot be 1 plus x. 15, not 14. Mm-hmm. Mm-hmm. Okay, so you are correct. But you have left the, what do you call it now? The number of ways. Because you are going to use, you have left the coefficient. Okay, the x, okay. Okay. Okay, so if you are talking about the powers of x, that's easy for you to get now. X squared. What about the numbers that come? You can leave the answer in combination. Okay.
105 x 155 x squared.
Okay.
1365 x. Oh, so it's 15 x,
50.
105 x.
Yeah.
455 x.
Yeah. So it looks like you're very, very proficient in this. So can you tell me what aspect of the pure maths do you think you have challenge? Go through the topic. Hmm? Yeah.
So let's work on the areas you think you have challenges. Because the way it's looking at that is like I've learned so much. I don't want to teach what you already know. So let's focus on the area that you need help and start with to go through the topics that you want to think you should focus on that you need to. Then this one too. When I let us have some questions in this one to understand all this all the geometry and all this stuff. Okay, so let's just take yeah, those questions. Yeah, all those questions. Let me start with this. This one is very important. But that doesn't mean we don't know about this because this is the system. This is the system. So I wanted to show you how to use it. So we'll covered an aspect of this. So let's move on to differentiation. Sorry, what page is that? Just copy page for me, please. Page 190, okay. That's 210. Okay. So we're looking at simple derivative of the function, differentiation. Let's start with the graph of the function. So let's say the graph of the function is s squared. Usually the graph of s squared looks like this. Graph of s squared looks like this. Now, if you're asked to find the gradient of a graph at a particular point, so let's say the point is somewhere here. So what we usually do is we draw a tangent. The tangent is the straight line that touches the up at just that point. Okay? So this is the tangent. Why this is not a tangent? Let me draw a line. You have a line that goes this way. This is not a tangent because it's cutting the curve at 2 points. So the tangent generally touches the curve or the circle at just 1 point. And that 1 point is the point in question that you're asked to find the gradient. So if you're asked to find the gradient of this curve, f of x is equal to x squared at, let's say, s equals to 2. And use your algebra to thank you. Since you are not to this is something that so you draw your straight line passing through those points. So this is s equals to 2. And then you now want to construct your triangle. So if you construct your triangle, how do you find the gradient of the line? Recall that the gradient of the line or a straight line is given by the change in y, right? Change in y by change in x, which is the same as y2 minus y1 over s2 where y1 is the initial point, because there are 2 points on the vertical line. So this point is at the level of y1. Y1 is the distance from the origin above. So y1 units. And y2 is the distance from that same point. Okay, from here to this place is y2. Here to this is y. So this is the change between the y2 and the y. That's the difference between the two. This is the height of the triangle. Along the horizontal, x1 is the distance from here to here, while s2 is the distance from here. So the change in s2 and s1 will be the base of the triangle. So it's simply saying that dividing the height of the triangle by the base, which we also call the rise. Okay. Now, when we say changing doesn't necessarily mean that it has to always be an increment. It also be a change. Increment means when the change is actually what is going on, like when you're moving from the higher level to the lower level. Okay. So that's basically how we find the gradient of. So if you are to use the GeoGebra, so I'm going to just use the GeoGebra to show you how to do that. So first of all, we'll draw the line. When I'm done with it, I'll just show you for you to see how to do that. So I'm drawing the graph of y f of x equals to x squared. X squared. So this is what I have. Just take a look at it. And at s equals to 2, I want to draw what they call it now, a gradient, a tangent. So I'll pick my point. So I'm going to pick the point which I'm going to use now. So this is 2, right? So I want to draw a line. Please look at the diagram. So that from this point, it meets the red line, the curve, at exactly where it's meeting there. So I'll go to tools. Please pay attention. Then I'll pick like a line that goes from 2. So I'll pick. So I'm going to pick. So usually it's better to use what we call perpendicular line, because when
when you pick a perpendicular line, so let me pick this one. Hello? Yeah, good morning. How are you doing? Yeah, this is Mr. Abraham. Yeah, same to you. Okay, yeah. Yes, yes, please. Yes. Okay. 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 You need me for any of the competition, Olympiad? Do you need my attention for the Olympiad or okay, so we'll discuss on WhatsApp. All right, I'm much available. Yeah. Sure, sure, I will. All right, good. Sorry about that. So now we can take the perpendicular line from here. Okay. So and then we pick this point, exact point at 2. Uh, so let me do this again. Select a line, select a perpendicular line and point. So I'll pick the perpendicular line. So this is the point here. So this line s equals to 2 meets the graph at a particular point. So let me find where it meets the graph. So I'm going to use what we call intersect. So this intersection of the points. So I'll click on this. You see that? Then I'll draw my tangent. So I need a tangent. So I'm going to go to the line. So this is tangent. So if I click on it, this is very easy to use. Just see, they'll give you a kind of auto suggestion on how to use the function. So when you click on the software, so select a point or line, there's a circle. So the point in question is this point here, right? And so that's it there. I can change the color so that it's going to be a different color for me. Just set it color and then change it to let's say green, just to differentiate it from. So that's the point. So I can call that point, let's say P, if you like. So if I want to draw the gradient, I need to construct a right angle triangle. So I'll construct a right angle triangle. So it doesn't necessarily mean that I can use anything provided it's a right angle. So I'll go to point. Where's point? So I can pick somewhere here. You get it? I want to use this point to pick somewhere here. Pick somewhere here. So I would use a line segment to join those points together. So I'm picking a line segment. This is a line segment. So I'm joining C to E. Are you seeing that? And E to D. Okay, so I've constructed my triangle. Let me color everything in green so that everything will be consistent with what we are learning. Hope you're following. So that's for that. Then for this motion, change this color to green. All right. So to find the gradient, all I need to do is to find the length of DE and divide it by what? So how do I find the length? So I'll use a function. So please try and master this GeoGebra because it's really very practical. It helps you to, like when you're learning maths, it makes the maths be more complex, not like theoretical. So that's the reason why we are making use of some of all these tools. So you go to length, there's a function called length. So, this distance measurement. So once you click on it, it will explain to you how to use the function. So select 2 points and then a segment. So the 2 points here in question is D and E. So the length is 7. Okay. Then C and E. That's 1 point. So let me do the calculation. So to do the calculation, I just come to algebra and then I come here. I just say DE divided by, because DE is the height, okay? So DE divided by CE. So can you see what it's giving me? It's giving me 3.9999, which is very close to 4. But it's actually an estimate. If you do it correctly, you should actually get the value of 4. Are you following? Right, so let's move on. So if you do the calculation, the right value for this graph of f of x equals to x squared is exactly 4. How can we use the knowledge of calculus to actually find the derivative of this function? So to use the knowledge of calculus, we're going to do a little bit of adjustment to this stuff. So what is a little bit of adjustment? So what we are going to do a little bit of adjustment we are going to do this. So this is the graph of f of x is equal to x squared. Okay? Now, the point in question is x equals to 2, right? So somewhere here. So what we are going to do is we will we'll draw a line now. So it's not entirely we're going to draw. We'll draw a line from this point to this point. Can see that? And then draw this line, we'll bring it down. Just follow me. Then we'll draw this. Now I'm going to use a very powerful concept. So this is my y-axis. This is my x-axis. Now, let's call this point S. Of course, S could be anything, right? This is like our x is 2. Now, if I move from here to the in calculus, a change in y is simply written as delta y. Means what? Change in y. And I told you the change does not necessarily mean it has to be an increment, it can also be a decrement. Then the change in x is written as delta x. So don't forget about this great symbol. They're very, very important. So which means our gradient is the same thing as well. Change in y by change in x. So now, if I'm at this point, which let's say x, for me to move to this point, I need to add the increment. So for instance, if here is 2, so let's say our x is what? 2 or x1. You want to write, right? Moving to another neighboring point, let's say this is 6. I'm just using for example, that's not the actual. This example, I think is 1 and 2. For this one, is just 2 and 6. So x2 is what? 6. What is the change in x? The difference. So the change in x is equal to what? 6. So x2 minus x, which is 6 minus 2, which is 4. So if I have a particular value, let's say x, which is my 2 now, and I want to move to s2, all I need to do, if I want to get to my s2, is to add x1 plus change in x. Am I correct? Which is 2 plus 1, which is 6. So what I'm saying in essence is that if I'm at s, where s could be any value, to get to my other point, I'm just going to add x plus of change in x. Does it make sense? Similarly, if I'm at a particular value for my y, recall that my y is actually the function of x, isn't it? So in this case, what is my y? X squared. Does it make sense? So let's say my y is, like in this example now, the y is, I think, 1, while the other one is 8. So y here is 1, then y2 here is 8. So y1 is 1, y2 is 8. What is changing y? Y2 minus 1, which is what? 8 minus 1, which is 7. You get it? So if I'm at y1 and I'm going to y2, I just need to add y1 plus change in y. So if this is an arbitrary one, and I want to move to y2, all I need to do is to add y plus change in y. You get it?
So my y is f of x, which is equal to x squared. Then my y plus change in y will be f of, now, the value of the corresponding value of the function is going to be what? F of x plus change in x. Do you get it? Then, which is going to be what? X plus change in x also. Does it make sense to you? So now, my gradient, which is what I'm looking for here, or gradient function. So the gradient function or the gradient of the, or call it the gradient function, because at the end of the day, the kind of gradient you're going to have is going to be like a function. So the gradient function is going to be change in y by change in x. So change in y is the difference between this whole place from here to here. Okay? That's this height. That's the change in y. Change in x is what? This guy here. Are you following? So what is my change in y? My change in y is actually the value of the function, which is what? F of. So this point is out. This point is the same thing as f of x plus change in x. Why this is the same thing as f of x? Are you seeing it? So my change in y here, which is my height, is what? F of x plus change in x minus f of x. You get it? And my change in x is the same thing as x plus change in x is the same thing as change in x. So my gradient function, change in y by change in x, is the same thing as what? F of x plus change in x minus f of x by change in x. So in this case, what is f of x plus change in x? That is x plus change in x all squared minus what's f of x? X squared over change in x. Are you seeing that? So let's do expansion. You can see we now need the knowledge of the binomial expansion of x. So when we do the expansion, we have s squared plus 2 x change in x. How do we do that? By using the binomial expansion plus x squared minus x squared over change in x. This is the amount. So this will go out. So this is going to become, this will balance now with 2x plus, I think I'll make a mistake here. This will be change in x plus. Hope you agree with me. This is the binomial expansion. So we now have 2x change in x plus change in x plus by change in x. So we should now be 2x change in x over change in x plus change in x plus over change in x. So this cancels this one, this one. So we have 2x plus change in x. Do you understand? Please just take this. So our gradient function, change in y by change in x is equal to 2x plus change in x. So this is our gradient function because we get on the value of the what? Of this function. Do you get it? Are you following? But this thing, this is not the actual gradient we are looking for. The actual gradient we are looking for has to pass through this point. So Penny, what do you think we are going to do to get the actual gradient? So let me say, for example, I'm going to do for example, let's say our change is 0.1. So since in this question we're looking for the value of the gradient at s equals to 2, right? So the gradient function at s equals to 2, s equals to 2, because 2 times 2, 4, plus change in x. Change in x is the outside of the base of the triangle. Let's say we have a change in x of 0.1. So the answer to this is what? 4 plus 0.1 is 4.1. Isn't it? But that is not the actual gradient you're looking for, because the actual gradient has to be a tangent that has to pass through this point. So this line is not a tangent. But there's a little trick we can do. If we try to make this smaller and smaller, what will happen? Then this point is going to come somewhere here. Are you seeing it now? I get it now. It's becoming small. Right? So this guy will get it smaller too. If you make it smaller again, you're going to get it smaller too. But as it's getting smaller and smaller, change the width, which is the height, will also be getting smaller too. So what happens if, let's assume that it's possible that this thing gets so small that it's not so big. So you discover that that line, which is not a tangent, is actually going to be almost equivalent to the tangent line. Am I correct? So when do you think is exactly going to become a tangent? Yeah, no, change the length is very, very small. That's 0.0000, so small. And you see that that line, we actually want to prove that is the tangent line, like just like this one. So at what point do you think it will exactly become a tangent? It's adjusting the value of change x. It's going down, change y is going down. But our goal is to actually find the gradient at the point. So at what point do you think is just going to be a gradient at that point? Isn't it going to be when the value of change in x becomes equals to 0? Becomes equals to 0. Isn't it going to be when, because if change x is very, very small, it cannot be smaller than 0, right? Like 0 has to be the last final destination, am I correct? So the point is that if change in x, we know it's not possible actually because of the can't construct a triangle at 0. But let's assume it's possible. Then it means that this line that looks like this, sorry, it's looking somewhere like this. It's going to be like this. Do you understand? That's when change in x ends. So we'll say that is the limit of the function, the gradient function. The limit. Limit means when you are changing the value, when the value of the variable is getting close to or approaching the particular, what will the function approach? Are you with me? So let's take the limit of. So to take the limit, it's important for you to take the limit because we are actually finding the gradient. And from what we know, to find the gradient, you have to draw a tangent. So this one is not a tangent. So to find the gradient, we take the limit, is usually written like this, of change in value at change. This is our gradient function. And change in x tends to what? 0. So something is going to happen. So this change in x becomes so small that it's going to become negligible. 0. So at the end of the day, you're only going to be left with what? 2x. Okay? So the ratio of these two quantities, as change in x is tending to 0, change in y tends to 0. Am I correct? So it's not going to be like 0 over 0. This whole thing is going to tend to what we call the gradient function or the derivative of the function. Do you understand? So the ratio of these two doesn't become 0 over 0. It changes to what? The derivative of the function, or what we call the differential function of the function, which eventually becomes what? 2x, because at the end of the day, this one has become 0. Do you get it now? So at the end of the day, if y is equal to x squared, then the y dx is what? 2x. Now let's look at it. So when x equals to 2, then the y dx will be what? The y dx at x equals to 2, the 2 times 2, which is what? 4. Which tells you the reason why when we did the actual calculation using the software, our value was what? 3.9999, which is very close to 4, right? Because of course you can't get the 100% success if the diagram is very, very important. You have a question?
Any question? All right, so just try. So jot down 1 or 2 things so that. Okay, so there's no question. I have another class. So we're meeting when uploading next meeting. Thank you. All right. Thank you. No, let me get one. I can't do that because I can't rush now. I have to. I'm recording now, so I'm on live, so First of all, I want to ask how was the exam? So I also like to walk through the exam questions and from there. Okay, so like I said, you can always go home and go through the live stream so that you get access to all discussed. Or so it's only when you come to school. Wow. Okay, so let's just review the exam questions for today. And this is a calculator math problem, so you can always use your calculator. So I'll focus on the ones that you need better explanation, probably that you didn't get during the exam. So the first question,
Okay, okay. I use the calculator. Let's make the class faster. So, the first question says, find the value of, so I just
put myself through for that.
the value of the cube of um,
3,
75.
okay. So usually you're expected to use your calculator, estimate that, and when you're done, you now leave your answer. You are specifically not told to leave your answer to any decimal place or single place, but I think it's always important that if you are not asked to leave it to any number of decimal places, just leave it to like let's say 3 decimal place or 2 decimal place to maybe on two singular figure. So for this question, I'll just use my calculator. I have a calculator here. So let's use our calculator. Please ensure you bring your calculator in the next class. Um, so the functions. I'm not even saying cube T, I'm saying square root. That's, it is a scientific calculator actually. How is that? Okay, it's let me send out the link. Joyce is chatting me up. Send the link. Video live stream. If you are free. center the live stream. Okay, so using the calculator, you are not able. Please, we are coming to lesson. Come to calculator on your laptop. Why you think that? So using our software, it's very important. In my class, I emphasize on practical stuff. Because class will become boring if you don't put some of those elements. You understand what I'm saying? So I always want to ensure that I use technology in my lesson as much as I can. So 337 keyboards. I'm struggling with technical and scientific calculus. All these ones is showing me uh, it's not giving me what I want. Just seeing, I'm not seeing keyboard, and I wonder why it's not there. I only see square roots. I don't want square root, I want cube. So I'll just go to, let me just say cube root of 337. Turn it direct. So I got 15. Was that your answer? So that's it. That's exact value.
Second question says calculate 4 raised to the power
Of 5.
minus 5 raised to the power 4.
I hope you got this one too.
So 4 raised to the power 5 is that's multiplying 4 and 5 raised to 5. That would be
You have to use calculator. Most of these stuffs are calculator stuff. 4 raised to the power 5. Let's see what 1000.
so 4 raised to the power 5 is 1024. 5 raised to the power 4
4 is 5 raised to the power 4 is 6 to 5.
so the difference will be
1024 and 625. So that will give you 399. I think you got this one too. The next question is more like a tip. That's why I hope that screen will be working tomorrow or anytime we have class again. So we have a table. Temperature is in degrees Celsius. The record at the same time in 6 cities. Which city has the coldest temperature? So I'll just use Dortmund here. So we have 6 cities. 1, 2, 6 cities. But who 4 cities right now? Followed by Helsinki. Helsinki. I've not heard of that city before. Helsinki. Then we have Oslo. Oslo now should be in Paris. And then so now we have the temperature to be 6, -2. Then we have -5. Then we have 7. Then we have 9. Yeah. So now the first question says, which city has the coldest temperature? So which city has the coldest temperature? Definitely have to look at the one that has the most humidity. That is Oslo. So that's that. I hope you got that. B says, what is the difference in temperature between Helsinki and Paris? And so difference in time, or just short is between
Simple and Paris. So Helsinki is -2. Paris is 7. So now this difference will now be like this. Let me show you. Here is 0, right? On the temperature scale. 7 is from here is 7, right? -2 is this below. So the difference will be what? 7 plus 2. So another way you can put it is 7 minus -2. Power is 7 plus 2, which is 9. Don't want to make a mistake and say 7 minus 2. 5. It's not 5. Except if this one is 2 and this one is 7. So if this one is 7 and the other one is 2, it's going up to number 9. Difference is what? 5. You get it? Or if one is positive or one is negative, difference is add both. If both are negative, difference is what? So if one is 7, -7, -2. Difference is still what? 5. It's going to be -5 because it's below the reference, which is our 0. You understand? Very important. So for that one, the difference is 9. Okay, I think that sorts that out. The next question is standard form. Says write the following in standard form. So write 0.20 followed by 273 in standard form. So in standard form, it definitely means you remove the form. How many times you can shift the decimal point? One, two, three times, right? Because you have to always be between the first two significant numbers. That will then be 2 minus 7 times 10 is power. Because it's 0 points, so you don't have a negative power. 7 is not 0 point. For example, let's say it's 273. Then we'll definitely be moving this way, right? Or we are moving this way to the negative. How many times? 1, 2, 2, 2, 3. Question. That's also one mark. Question 5. About estimating, calculate the value of, so calculate 1 minus 0.7 divided by 0.45 minus 0.38. And then your final answer, leave it in 4 significant figures. So this one, I use a calculator of this. Okay, start. Let me try to do the top. So this is going to be 1 minus 2. That will be 0.35. Let me do the bottom. This will be 0.45 minus this. If I add 7, I think I'll be fine. Am I correct? Or 7 plus 2 units, right? Because it is 5. So I can shift my decimal. See both of them on the same decimal place. And 3 over 7. 3 over 7 plus 1 is 0.30. Let me just use calculator to finish that up. So that we can now find the number of decimals. So 0.424287. Let's talk about that first. 42857 to 4 significant figures. According to we have to analyze up to this point. That will be 0.4286. 4. Okay, so let's move on. That's too much actually. So okay, the second question is question 6. It says that J equals to 4K plus 7N. And then find the value of J when K is. So when K is -5 and N is 6, what is the value of J? So you simply say you substitute what you have into the expression. So this becomes J equals to 4 times -5 in bracket plus 7 times 6, which will be -6.
straightforward. That's also 2 points. That the seventh question is actually a one problem question. I'm not going to write it out, I'm just going to read it out so I can interpret it. So it says white paper cost W cents. So white paper costs W cents. The cost of white paper, costs of white paper is W cents. Alright? And okay, per sheet. And the second question says, an ink paper costs P cent per sheet. So the cost of ink paper costs P cents per sheet. Okay. Now, Mingwell used 56 sheets. Mingwell used 56 sheets of white paper. And 21 sheets of ink paper. 21 sheets of ink paper. All right. So now, the question says, write down an expression in terms of W and P for the total cost in cent of the paper used. This is straightforward. If cost of white paper is W cent per sheet, then how much will the 56 sheet cost? That will be 56 times. Then, if cost of ink paper is P cent per sheet, how much will 21 cost? That will be 21. So the total cost will be what? Total cost. Be the sum of the two costs. That's 56 of the cost. You can't understand. You get it? Because there are two different items. So you just write it out like that and get your 2 marks. Question 8 is about factorization.
Maybe you can give
Okay, done almost everything. Wow, that's good. So factorize complete 1 plus x minus y minus xy. Okay. So to factorize is simply find the common term. So what is common between this? I think y is common, right? So if I take the problem is that if I take y to be common, I'll be left with negative 1 and negative x, which is not too good for me because of what I have here. So you have to be actually very smart. So but if I take negative y, I want 1 plus x, isn't it? Which is common to what I have here. Assuming this is a bracket. You get that? So which means I can take a common term. So the common term is 1 plus x. What is left? 1 minus 1. Do you understand how I should take the beginning? Get it? Alright. So it's a very simple factorization. Okay. Alright, question 9. Factorize completely. We have 2s minus 18 xy squared. I hope so. I hope so. Yeah. So all we need to do is to use the highest common factor. The highest common factor, first start with the numbers. Highest common factor of ACF of 2 and 18 is 2. The ACF of, let's use x cubed and x, is x. And ACF of, for this is 1 and y squared. There's no, it's 1 after because both of them is 1 and it's 4. So the highest common factor is 2 times x times 1. That was 2x into brackets. So the left is what? X squared. Because x times x squared is going to be x minus 2 divided by 18, that's 9. X divided by x, 1. Y squared will be left. Okay? But it says factorize completely. So the student might stop here, but you will wrong. Because this can also be factorized using what we call difference of 2 squared. Have you heard of difference of 2 squared? So let me explain what difference of 2 squared. The difference of 2 squared, I'm going to use
how would I use for different time? So okay, I can use that. Do I still have my subscription? I don't use that. So I'll just draw it on the board. So using algebraic type, how do you express the product of, so let's look at this area of I think the rectangle or whatever. So now we have here to A box. This is B. So this is what this one is. And then we have this other side of the box. A. Nothing is here. So let's see what is here is B. But what should have nothing is here, like there's no B here, so B has been subtracted out. So this area is going to be so this and this will be A square. So this is going to be so basically what I want to show is that if you have A plus B times A minus B, if you multiply the two of them together, you're going to have A times A is A squared, A times negative B squared, negative AB, B times positive A is positive AB, B times negative B squared, negative B squared. So this will cancel out. So at the end we have A squared minus B squared. So A squared minus B squared is called the difference of two squares. The difference of two squares. So anytime you have the difference of two squares, you can always factorize them into A plus B minus B. So why do we need this to factorize it? Because if you look at this, initially it doesn't appear to be the difference of two squares. But when you now look at this 9, if you make 9 to be 3 squared, this will be 2x into x squared minus 3 squared minus 1, which can also be written as 2x into x squared minus 3y all squared. Okay. So if you look at it that way, you know that this is actually the difference of two squares. So this is your A is your x, your B is your A. You just use the formula for difference of two squares. You cannot use the previous. Otherwise, you don't get a complete map. So instead of any factorization that you have to use some of this identity to finish up your work. So let's call A to the x squared and B to the y. So using difference of two squares, you have A squared minus B squared to be A plus B times what? A minus B, which is the same thing as what? X squared minus 3y all squared over A, which is x squared, plus B, 3y, into A, x squared, minus B, 3y. So at the end of the day, the factorization of 2x cubed minus 18x y squared will be 2x into x. So we are not factorizing this now. X, sorry, this is x plus y squared. X plus 3y into what? X minus 3y. So when you do this, you have your final mark. Which I believe that's what the mark there was 3 marks. Because they know that some students might make mistakes. It's actually not that if you know what to do. The next question says expand and simplify the following expansion. So the expansion of 2 plus 2x plus 3. I wish you guys have a laptop. I'll show you how to use algebraic type to do all this stuff. I should do a video of that. So we'll help you to all this quadratic, linear. There are so many things that makes maths to be very concrete to you that you just like, so this thing is actually easy. Because using letters for you guys kind of help. Number one, it can be boring and it's easy to hard to figure out. So now we start with this x minus 2 also. Okay, so let's start with x minus 2. So x minus 2 also is same as x minus 2 minus x minus 2. Then x times x times negative 2 negative 2x times x negative 2x negative 2 times negative that will be minus 4. So this will eventually become x squared. Collecting like this become
you can now multiply 2x plus 3 times the whole of this becomes x squared negative 4x plus 4. So let's do the multiplication. So this is my linear multiplication. If you know you'll be confused, I think just break it into two parts. So multiply 2x by x squared minus 4x plus 4, and then multiply the 3 plus 3 by x squared minus 4x plus 4, then add them to them. So I'm doing this way so that it will be easier for you to understand. So 2x times x squared plus 2x cubed plus x times x squared minus 2 negative. So here you have to be careful. Start with the sign, followed by the number, followed by the letter. That is the number you should go. So I started with the sign. Now 2 times 4 8. So I'm done with the number. I'll go with the variable. Now x times this 4 s squared. So next thing I start with this line. The sign is what? Positive. And go with the number 2 times 4, that's 8. And go with the variable. S times 1 is x. So I'm done with the variable.
the next one, which is this part. Let's finish it up. So 3 times x, that's 3x squared. So we start with the sign. Plus times minus is minus. 3 times 4, that's 12. Yes. So all this time, most things with algebra is you have to do systematic and so you know then you have plus 3 times 4, that's 12. So we can add them together. So add them together. 2s cubed doesn't have any cube, so you bring it down. Get it? So you can shift ahead. Negative 8s squared plus 3s squared. So just think that negative 8 plus 3. That would be negative 5, right? Negative 5x. Then you have plus 8, negative 4. That would be negative what? 4x. And then this one doesn't have any stuff. So that's the expansion. Okay. Nice. A bit complex, but it's doable. Okay. Question. So that's 3 marks for that. Factorize completely. 14 s plus 49 x. Like I told you, start taking the highest common factor of 14 is the number 7, right? And then highest common factor of s2 and x. That's x. So the factor of that is 7x into 7 times 7 divided by 40, that's 2. S divided by s squared, that's s squared. So that will be 2s squared plus s squared plus 7 divided by 49, that's 7. X divided by x 1. Now we have 2x plus 7. I will simplify for that. No, you can't do anything for it. So that's just 2 marks for that. Question 11. Question 12. Say simplify 5g. So simplify the following expression. 5g minus 3h minus 7g plus 6h. So all you have to do is to collect the items. When you rearrange 5g minus 7g minus 3h plus 6h becomes negative 2g plus 3h. So you can't do any other further simplification. The next question, question 13, says factorize completely. So factorize completely. Always take it off. So that you don't fall into any trap. Completely 14 x y minus 7 y squared. So again, highest common factor of 14 and 7 is 7. Highest common factor of, okay, let's just say x and 1 is 1. And highest common factor of 1 and y squared is y. So that is going to be 7 times 1 times y, that's 7y into 7 divided by 14, 2. Y divided by xy, that's x will be x, minus 7 divided by 7, 1. Y divided by y squared, that's 1. So can we further simplify? And then we can't. So that is for that. If you want to write, looking at the syllabus, let me see those topics that okay, so we have, I think we saw our perimeter area and volume. So the next topic should be introduction to probability. Look at sequence, solve and set. There's so much to cover in this
discuss straight line and quadratic motion, Pythagoras theorem and similar shapes, average and measures of spread. Then we have understanding measurement, further solving equations and inequalities, scale drawing, bearings and trigonometry, scatter diagrams and combinations, managing money, curved graphs, symmetry, histogram and cumulative frequency diagram, ratio rate and proportion, more equations, formulas and functions, transformations and vectors, probability using tree, Venn diagrams and tree diagrams and Venn diagrams. Okay, quite a lot to cover. So, I didn't get you. Okay, sure. So let's just finish up this question.
So, do you guys do the government of that? Or the joint everything?
Well, I need to. I need to.
You only small paper.
Yes.
What happened? I think that.
They said it's just more paper.
So that means they didn't go by paper only paper two.
But that was the initial arrangement before I left. Okay, so for this question 14, it says
If B is equals to 3 minus 5, if the whole time is
yeah, that's right. Work out the value of B when
t equals 3. So find B when t is equals to 4. So this
for like substitution.
so substitute value is the expression now 3 minus 5 minus 4. 3 minus 20 that will be negative 16.
So that's straightforward. That's why you have 1 mark for that. The next question says make T subject to the same question.
So now make t the subject of the formula. Subject of the formula. S O B. So if B is 3 minus 5, to make it subject of the formula, but for me, I think it's better for me to make this here and carry this here. If I bring this here, this will become 5t plus 3 minus 3. Because I want to get the derivative. So I won't go further with it. So the right is 5. So t will be 3 minus 3. So that is
That's 1. 2 marks for that. Question 16. More like what problem? Is it a bag of rice cost
$100. So one bag of rice is $100.
cost and a bag of almond costs
$10. One bag of almond costs $8.
and the next Pedro buys X bag of rice and Y bag of
So Pedro buys X bag of rice and Y bag of almond.
okay. So the question says that write down an expression for the change that Pedro received from the $20. First, let's calculate the total amount spent.
So the total amount spent is, since one bag of rice is $100, then X bag of rice will cost what? $RX. Am I correct? And Y bag of almond will cost EY dollars. So total cost will be RX plus EY dollars. Of course, we don't know if this is bigger than 20 or less than 20. So if you are saying change, it means 20 is bigger than this. So the change, or what is left, will be 20 minus 20. RX plus what? EY. You can't factorize this. So you leave it. So that's 2 marks for that. Question 17 says simplify 3 into brackets
2a.
minus b.
So first we have to open
The brackets, so opening the brackets gives you 6a minus 3b which is going to be 6a minus 1. Okay, since this is simplified, I think this is factorized. What is common between the 2 is common. 2 divided by 6, that's 3a minus 2b is
Some of these examiners, they always looking at anything to mistake them. Next question is more like a statistical problem. Meanwhile, records the length of time of each telephone call he receives. So the data is given as
we have
711, 19, 612, and 820, 21,
23, 17, 14. Do you guys use them at the diagram? Use them at the diagram. 19, 9, 24,
and finally 12, 18. Okay, so now we said complete the frequency table. You will use the Stanley to help you. So here is the frequency table.
last 3 columns. So here you have the time in minutes, time
In minutes, yes.
time in minutes, and you have time, having this,
And your tally.
then you have frequency. So one of this, all this problem demands you to
So very careful.
so 0 to 5, that's the class interval. Interval of the class now 0 to 5.
The next we have
6 to 10. So the class interval is
from 0 to 5, 6 to 10.
11 to 15. That's the class interval.
Then we have 16.
16 to 20. That's the fourth class interval.
And then we have 20.
21 to 25. I think the answer prediction of the last one is going to be 26 to 30, right? Okay. So these are the various class intervals
In the question. So complete the table. Simply means
looking through the interval. How many times do you have a record that falls within 0 to 5? So you want to count this way or you want to go like that? I think my favorite is in this way. So how many do you see? 2. So you just put this and then put 2. Because this is how many? Also 2. And you just
Actually, it's not 2 years.
so you have to be careful. That's why the challenge with this topic is safe for us. You can always see the mistake. For this 6 to 21,
Says no. Says so. 7, 6, 9, 8.
1, 2, 3,
No, 9, 8.
4.
Yeah.
It's more, right?
Yes.
Okay. So this is 4. Are you sure of this one?
Yeah.
Alright. 11 to 15. 1, 2, 3. Plus 16 to 20. No, 4 to 21 to 25. So, how is the time mark for that?
So you just to be careful with what you are collecting. Then they say draw a bar chart to show the information and complete the scale on the frequency axis. So a bar chart
You know, the bar chart is different from histogram. For histogram, the bars will touch. So that's why you use class boundary so that when you have no, you use class, this is class interval. So for histogram, we give it class boundary. Class boundary is when this is going to be 0.5 to 5.5. This one is 5.5 to 10.5. Let me just show you how class boundary is. I'm just going to teach that one so in case you ask to draw histogram, you know how to do it. So if it's for histogram is usually like this. So if you have graph, so this is going to be, I think, 0.5. This will be something less than 0.5. So let's say negative 0.5. So you should be actually negative 0.5. Okay? So here it will be 5.5. So you add 5.5 here. So approximately 5. Yeah. So here is going to be 5.5 to 10.5. Here will be 10.5 to 15.5. Here will be 15.5 to 20.5. Here will be 20.5 to 35.5. Here will be 25.5 to 30.5. So the reason is because when you draw the graph, the bars will touch. That's why. So if it is bar chart based on what they are asking to draw. So they are asking to complete the sequence. Let me look at the intervals are given to 0 to 5. Then we have we've already given it to me there. And 16 to 20, 21 to 25. Yes. So what I need to do is where they give me that record. So I'll just go to my that's 2, right? So my highest value is 5. So those you can see 1, 2, 3, 4, the rest is 5. So that is my frequency axis. So now I'll draw a bar corresponding to 2. Note the bars has to be equal in width. Then I'll go to 6 to 10, that's 4. So the logic with this, don't forget, they have to be different. Then 11 to 15 is 5. So equal width. Then 16 to 20 is 4.
So, if the 21 to 25 is not to actually
Wow.
21 to 23.
2 down to 5 is 2.
Yes.
So that will be this is 2. And 20 is 2. That's 1. Okay, that's the bar chart frequency. Bar chart. So now it is histogram. Just read it because I'm doing histogram. So if it's histogram, we'll be having all these class values. So 0 to let me say 5, 5 to 10. I'm just trying to give you a value. 10 to 50. Here, better I put 0 here and move this one a bit. So that here is 0, move this a bit because of the negative stuff. So here is 0. So usually 5.5 is somewhere in 11, then 0.5 is somewhere in whatever that one is, that's the analysis to be. Here is happening. Or it's the negative. Yeah.
goes to 4. That's the essence because when we join the last class interval of the particular class will become the first class interval of the next class. So then the next one is 15, 10.5 to 15.5, and that's 5. And we have 15.5 to 20.5, which is yeah. And then you have 25.5, which is 2, and you have 30, which is 2. So that is the difference between the two graphs. It's not always funny. It's always very important so that you won't make mistake. So use the bar chart to write down the modal group. Modal group is the highest, the one with the highest frequency. So you use the use the chart or use the bar chart to write down the modal. So you use the longest, the one with the longest bar. The other has to use it. So you have to use this. So the one that has the longest, the tallest bar is what? 11 to 15. So for that question, 11 to 15 is the modal. So that's the answer to that one. So that's 1 mark. Antonio, giving us another. So let me just do some follow-up question on this. Question we asked. Modal mean the mean of the class. So we can use the table for classification. So this one is good frequency detail. So you have the frequency, which is also called F. Then you have your class interval. But the problem with this one is that if you want to calculate your average or mean, you need to find out what the mean value, class mean points. So if I want to do that one, let me just create it here. So the class midpoint, mid value or mid class, mid value of class, which is also called S, is the average of these two, or is that the midpoint? That's what we use. Except if they give us 0. So 0 plus 5 is 5. Divided by 2, that's 2.5. And then this one is 16 divided by 2, that's 8. For this one, 26, that's 13, right? For this one, 36, right?
9 is 80.
80, right?
Yes.
And this one, 46 divided by 2, 20. And finally, we have 26 plus 30, that's 56. 28. 28. You can see that there is a pattern. Like, forget about this one. From here, 8 plus, I think, 5, 13. So, some of these things, they all have the repeatable. So, once we are doing it, you can use it to check what we are doing. So, now the class, so now that we have your mean value of your class and your frequency, because the formula of a group frequency that is summation. Summation is total of f of x plus summation of f. When summation of x is the total frequency. So for say let's get the product of the frequency and the mean plus m. So f of x is mostly. I'm going to bring in a question that comes out under this. So f times x, so 2 times 2.5. That will be, I think this one will even be 1 to make sense. So that 1 plus 5 is 6. Or 6 is 0, so let's just keep it in the 80s. So 2 and there, that's 5 over 2 times 2, 5. Right? 4 times 8, 32. 30 times 5, 65. 4 times 18, 52, right? times 23, that's 46. And 1 times that is 28. So what you are going to find is the sum of summation of f of s and summation of f. Summation of f is also known as your cumulative frequency. So you don't add everything here. Let's do the addition. 2 plus 4, 6. 6 plus 9, 11. 11 plus 4, 15. 15 plus 6, 17. 15 plus 8, 18. So everything there is 18. Now let's do summation of this one. 5 plus 32. 37. 37 plus 65. That's 1 root 2, right? 1 root 2 plus 72. That's 174. 174 plus 46. That's 220. And plus 28. 8, 4, 2. So we add everything here is 248. So 248 divided by 18. That's making
Unless you teach because if that's which you
I know what I was then I was that you agree. So 248. Because you can't do without using calculator of your next lesson. Divided by 18. 30.7.
that will mean of the class. And we ask what interval for will be the mean. Okay, no, we can't ask you a question. Okay, yes. Because the mean of the class, 30.8 is the mean of the class. Okay, so that's hold on, this yeah, the mean that's to do with I think we'll get to the class interval for the mean. But we multiply the frequency times time. Okay, yeah, you can. So 13.8 is let me see. 11 will make it 15. 15. It was within here, right? Yes. So it is interval. 11 to 15. What is the interval as a modern group?
start the question. If what if like in the example, like you see it was 13.77. You don't indicate that you should make it, you should put it to one decimal place. You might just leave that decimal place.
The last thing we ask is the median class. The median class. So we go to the main class, which is the same as the median class. So the median class is the middle of the class. So there are many ways of doing this, but one of the ways I usually explain to my students, you can try and use the cumulative frequency. So let's do the cumulative frequency. From the table, we'll try from the table, once we use the graph, we'll try and use this one because this one will give finding. So now, cumulative frequency is, we start with, this is 2, right? So the next one, we know that 4. We now add 2 plus 4, that's what 6. If you add in, then 6 plus 5, that's 11. 11 plus 4, that's 15. 15 plus 2, 17. 17 plus 1, 18. So when you use your calculator, your last number is 55. So now, the rule says that if the value of a cumulative frequency is let's even take an example that you spread out some items. Let's say 1, 2, 3, 4, 5. This odd number, right? The mean is always try this, 3. And how do you get it? 5 plus 1 plus 2. So if it's an odd number, it's easy to calculate it. Just add n plus 1 plus 2. That's 4, that's 5. But if it's an even number, like let's say 1, 2, 3, 4, and even this 1, 2, 3, 4 as the values of your data, which also happens to be your position. So position and values are two different in this statement. Like I can use 10, 11, 12, 13. Okay? They are also for 1 to 2. So the position is 1, 2, 3, 4. But the values is 10, 11, 12, 13. Well, just for this example, I'm using those positions to mean the same kind of values. So now the mean, this comes to this. So you can't actually find the mean of this is going to be the middle of these 2 and 3. So usually what we do is we take the even number divided by 2 So 4 divided by 2 equals 2. Then we know that it's in between 2 and what? The next position 2. This will always use position. So I'm just so between 2 and 3, so no is what? 2.5. You get me? So if that's my position and my values are the same. But if they are not the same, let's say I'm using 10, 11, 12, 13. So I know this is out. So I know this is between these two and these two. So 1, 2, 3, 4. Position is 4, not 13. 4 divided by 2 is 2. So I know between 2 and 13. So that will be at 2.5. So if I go to my position, I go to between 11 and 12, which is what? So you do the same time, since my total, because my own rate frequency is the total number of items I have, especially if I spread it out. So I'll use 2 methods. This is the longer one and the shorter one. Let me start with the shorter one. So the shorter one now, 18 is even number. 18 divided by 2, 9. So my mean is between 9 and what? 10 as position, right? Which is my probability frequency. So if I go to position 9 and 10, where does it actually fall? It doesn't fall here because it's below there.
It should be where it is.
Somewhere here, right? So if I trace, this is the class. That's the median class. So we are meant to be between 6 and 10. But the problem is that sometimes there are formulas, many formulas. So for now, I don't want to do it. You want to actually locate the actual value of the mean in this class, but you know it's between 6 and 10. So that's why we now have to rearrange. So let me write it here. So rearrange them in ascending order. So let's do that. I think from what the lowest? 3 is the lowest, right? So 3. But my brain, I know that after I count now, my additional. So I know it's between 9 and 10, so I can get to that. So 3 followed by what? 4. So let me describe it out. Followed by what? 6.
9. It's from 7. 7 before 9.
7.
Yeah,
Yeah. How much? Okay, 9. 1, 2, 3, 4, 5. So in my head, I'm counting to that. No, we are actually doing. After 9, we have what? So take note of this one I repeat because we repeat them.
you forgot 1.
8.
8. Yeah.
Okay.
Now,
This is the right. They repeat meant to repeat. So 1, 2, 3, 4, 5, 6. We have like 3 more. 10. It's 10 here. It's 11 here.
yes.
11. Only 1 times. Okay. 12. 12.
It tries to work.
Twice, right? So you write it like this. Not just once. So how many do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's more on the left. The what? 13 is on the left. 14 is how many times? Once. So using your position, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9th position and 10th position. So what's the actual value? Between 12 and 14. So does it actually? So you can see that. Hold on. So that thing should fall here. Right?
Yes.
3. So the miss. Okay. So what it tells us now? We have 18, right? We divided it by 2. We have 9. So 9 and 10. And when we use what this is multiple 10. So the challenge here is that okay, we can't use this. So it has to be this. Do you know why? Because if we say it's going to be this, 2 plus 6 is already 8. And 8 is less than 9. Like if we arrange the what is it? 1, 2, 3, 4, 5, 6, 7, 8. So the 8th number is 12. So it will not be in this class. You grab me. So the idea is that if you calculate and what you have, you know when you count 9 now, this is not 9, and this is also not 9. So you don't use the lowest, you come. The reason is because if you use this one, and 2 plus is not. Sorry. 2 plus 4 is 6. That's less than 11. Not 2 plus 6, 2 plus 4 is 6. So use this one. So it should fall, the median class should be here. I want to get 13, which fall into 15. So the median class is 11 to 15. That's I think we'll stop here because we want 40 the rest of the system. I believe there's no question. All right. So
We'll meet again. All right, good.
our next class is on Thursday anyway. Well, I want to come for the art maths because I have art maths tomorrow.
What do you have yet? Huh?
Tomorrow.
All right, no problem.